So we're going to be doing derivatives with polar coordinates, polar curves. And so we have our formula is right here. And what we're going to do first is form that formula because it's fairly simple. So our x is in terms of r cosine theta, and our y is in terms of r sine theta. This is what we know. Our r is also in terms of theta. So we actually have parametric equations here with parameter theta. So we can use our parametric equation formula, which is dy d theta, dx d theta. So let's take our derivatives. So we have dx d theta, and you notice this is just product rule. So we're going to do r prime, and then cosine theta, plus, and then it would be r, and then derivative cosine, which is negative sine theta. So you can see we're getting that dr d theta cosine theta plus, oops, now it's minus, right? Minus r sine theta. So that's our denominator here. However you want to write it, dr d theta or r prime, it's your preference. And so now the top would just be the same with dy. And this is also product rule. So dy d theta would be r prime sine theta plus r cosine theta. So it's our dr d theta sine theta plus r cosine theta. So this is our bottom, and this is our top right there. And so all we have to really do is find r prime, right? And then plug everything in, and we've got our formula. So once you find r prime, you just substitute it here, and we've got our formula for the derivative, because we're going to also know r. All right, so let's try one. So we have r equals 1 over theta. So let's prep this for derivatives. This would be theta to the negative 1. So our r prime, which is dr d theta, would just be negative 1 over theta. Oops, I went way too quick. Negative 1 theta to the negative 2, right? We subtract 1. So this is negative 1 over theta squared. So now we know r prime. We know r, and it's sine theta cosine theta. So our derivative, dy dx, would just be r prime sine theta plus r cosine theta, r prime cosine theta minus r sine theta. And we plug it in. So this is negative 1 over theta squared sine theta. And then our r is 1 over theta. And then we have cosine theta. And then again, negative 1 over theta squared cosine theta minus 1 over theta. Erase. Oops, erase again. Sine theta. So again, it's sine, cosine, cosine, sine, r prime r, r prime r. And there we go. And so now we can multiply everything by theta squared if we wanted to simplify this some more. But all we're looking for here is the slope of the tangent. So there's two options we could do. We could have just plugged theta into r prime right off the bat and got negative 1 over pi squared, and then plug that in instead. We didn't actually have to find the formula for the derivative. We just need to find the slope of the tangent. So we need to find dy dx for when theta equals pi. And so we're just going to plug that in. Negative 1 over pi squared sine pi plus 1 over pi, and then cosine pi, and then negative 1 over pi squared cosine pi minus 1 over pi sine pi. So you can see we're just plugging stuff in like any formula. And so we could just actually find each individual value here. That would be negative 1 over pi squared, 1 over pi. And then we already know what sine of pi is and cosine pi is. We don't actually have to plug these in, but we already did. So let's just finish it. So sine of pi here is 0. And cosine of pi is negative 1. And so negative 1 and 0. And this is why I was saying we don't need to multiply everything by theta squared and simplify all this to find a formula when things will cancel and work their way out when we have just basic numbers. So we have 0, so it's negative 1 over pi on top, and on the bottom we get 1 over pi squared. So if we simplify this, this is negative 1 over pi times, and we reciprocal. So it's negative pi. So the slope of the tangent, let's write this down here, slope of the tangent for when theta equals pi would be negative pi. And there you go. So now what do we need? We need to make more room. That's what we need to do because I ran out of room here. So I'm going to zoom in, shrink it a bit. And now I got more room. All right, so now we need to finish this. So what we need is the equation of the line. So in order to find the equation of the line, we need our x comma y, right? And so we know x is equal to r cosine theta, and y is equal to r sine theta. And so we just plug them in. So what is our r? Our r is 1 over theta. So we know our r equals 1 over theta. So r at pi would be 1 over pi. So 1 over pi, 1 over pi. And then this is just cosine pi and sine pi. See, we're just using r theta, right, to find this. And our theta here would be 1 over pi comma pi. Those are our values. And so we just plug them in. And so this again is 1 over pi times -1. So -1 over pi. And this is 1 over pi times 0. So 0. So our coordinates would be -1 over pi. That looked horrible. Those are arrows. There we go. -1 over pi comma 0. And again, this is now x comma y. See, we have a slope. And now we have an x and y coordinate to get the equation of our tangent line. So it's the same stuff we've done before. Y minus the y coordinate equals slope x plus 1 over pi because we minus it. So we get y equals -pi x minus 1. Now, on all of these, we want to just double check everything. So we have that. We have our slope. And so what we want to do is double check it. So we click on the Desmos graph just to get an idea of what everything is, and we verify it by plugging this in, and this should go through that point, which is that point as well. And so you can see I already linked it, and you can sit here and change your a to anything we want, but we want it to be pi. So right there is our value. So you can see that's our 1 over pi, and then that's our pi. All right, that's our polar coordinate, which gave us the rectangular coordinate of -1 over pi and 0. So just by plugging pi in here, it gives me everything I need. And you can see there's my -1 over pi minus 1. And that is the equation of the tangent. So if I click this little button, it should overlap it perfectly. And there we go. And so with these are already set up in Desmos, you can change the function to whatever you want. You can change your a to whatever you want, and you can move it around to see how it moves, what the slopes are. All right, we've already got our derivative, so numerator, denominator. So there they are together to give us our slope. Right, and then there's the equation of the tangent, just like we talked about before. But it will give you everything. And then you can just sit here and plug in the value you want, which we wanted was pi, and it'll tell us the location. Right, obviously 3.14, but it'll tell us what our slope is. See, there's our -pi to verify it, and then you can type in the equation to make sure that it is correct. So if you plug in the wrong one, it'll give you the wrong location, telling you made a mistake. And so there you have it. Now, this is just one method, which is use the formula. And so what you could do is if like, oh, you don't remember the formula, is just to do it by hand. So we know x equals r cosine theta. And what we're looking for is our dy dx is going to be dy d theta over dx d theta. So you could just take the derivative with respect to theta after you plug in your r. So we would say x equals 1 over theta cosine theta, and then now take the derivative. So dx d theta would equal to, and we already know the derivative of 1 over theta. We did that here, right? So this would be -1 over theta squared cosine theta plus 1 over theta. So you're just applying product rule, negative sine theta. And you can see there's our denominator. And then we would do the same thing with the y. Right? And so our y is equal to our sine theta, which would be 1 over theta sine theta. So we end up with the same thing, -1 over theta squared sine theta plus 1 over theta cosine theta. And you can see there is the numerator. So there's options. Use the formula or plug the r in and take the derivative with product rule yourself. And then plug all the values in. Lots of different ways to do this. So next video, we'll do another example.